Hello all, this is Yamuna from Trinity College of Engineering. I'm working as Assistant Professor in Electrical Department. Today we are going to discuss a basic theorem in electrical circuits, the Thevenin's theorem. For analysis of Thevenin's theorem, here we consider a coupled network. First of all, we need to know why we are using this Thevenin's theorem. Here there are two networks which are coupled and it consists of many resistors, independent voltage and current sources. Such a big network analysis is a tedious process. In such situation, Thevenin's theorem plays an important role by making the circuit simpler. That is, this application of Thevenin's theorem makes the circuit into an equivalent voltage source in series with a resistance. Now let us see the statement of Thevenin's theorem. Any combination of battery and resistance with two terminals can be replaced by a single voltage source VTH and a single series resistor RTH. The value of VTH is open circuit voltage at the terminal and the value of RTH is the value of resistance across the terminal, while all the current sources are open circuited and voltage sources are short circuited. Suppose network 2 is detached from network 1. We temporarily focus on network 1 and the circuit will be like this. This network 1 is a complicated structure with many meshes, resistance, voltage and current source. Now our aim is to find the voltage across the terminal AB. This can be done with the help of a voltmeter. If you measure this voltage, we will get a voltage VAB. This voltage is known as open circuit voltage. And it is also called Thevenin equivalent voltage VTH. Now, in order to find the resistance RTH, that is the equivalent resistance RTH, we have to implement or convert this circuit into a resistance circuit having many resistances, voltage sources and current sources like this one shown in figure 3. The first step to find the resistance RTH is to deactivate all the sources in network 1. And to deactivate the voltage source, we replace the voltage source with a short circuit. If we are using a practical voltage source, that is a voltage source having internal resistance, then instead of a short circuit, we have to replace it with the internal resistance. To deactivate the current source, replace it with an open circuit. Now the figure 3 will be like this. The voltage sources are short circuited and the current sources in these positions are open circuited. Now we will find the equivalent resistance Now we will find the equivalent resistance across the terminal AB with the help of a ohm meter, or you can find by our series parallel method. As you all know, but to find resistance without and help of an ohm meter, you have to consider a current is flowing or coming from terminal A and completes its path to terminal B. Likewise, you can find whether the resistance is in series or in parallel. Now we have got our equivalent voltage and equivalent resistance. The final step of this Thevenin's theorem is to connect the voltage source in series with the resistance across that terminal AB. Now the entire circuit is simplified to VTH and RTH. Now we can reconnect the equivalent network to the network 2, thereby helping the analysis to a easier one. Now we can make any calculations we desire with the help of network 2, and they will give the same result as if we still had network 1 connected. Let's see the analysis with the help of an example. Here we have to find Vx by finding VTH and RTH to the left of terminal AB. That means we have to find the voltage across resistor 2 ohm. First step is to remove everything which is left to the right to the terminal AB. And the circuit will be like the figure shown here. That is the figure 8. Now we have to find the voltage VAB. Here I have applied voltage division rule. As you all know, we will take the total voltage into the branch to which the voltage has to be taken by the sum of the resistances, and here we get 10 volt. Notice that there is no current flowing through 4 ohm resistor since AB is open. So there will be no voltage drop across a 4 ohm resistor. Next, we have to find the equivalent resistance RTH. In order to find the equivalent resistance RTH, we have to short circuit all the voltage sources and open circuit all the current sources. And the equivalent circuit will be the circuit shown in figure 9. And if you look at this figure and you consider a current is flowing through A and it ends in B, this resistor 12 and 6 will be parallel and 4 will be in series, and the equivalent resistance is 8. Now the final step is to connect the equivalent Thevenin equivalent circuit, that is 10 volt in series with 8 ohm, to the terminal AB, and we have to connect the resistance which we removed earlier, that is a 2 ohm resistor. Now it is very easy to find the voltage across 2 ohm resistor and whose value is 2 volt. Thank you.